ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi. You know about an atom, right? An atom consists of large number of minute particles. And you also studied about the Bohr concept of an atom, which explained the actual structure of an atom. But do an atom consist of any other particles? So many aspects about atom still remain as a miracle. So can we make a journey to the world of atoms? You know that in a modern periodic table, the elements are arranged on the basis of their atomic structure. If you know the atomic number of an element, you can simply predict the position in which the element belongs in the periodic table. Okay? Now let us consider one example. I am taking the element sodium. The atomic number of sodium is 11. So look here, you can see the electronic configuration of sodium as 2, 8 and 1. That means here the outermost shell contains only 1 electron, right? For most of the elements, there is a relationship between the number of electrons in the outermost shell and its group number. Here, the sodium belongs to group 1 in the periodic table and the number of electrons in the outermost shell is also 1. Okay? So, we can say that the sodium belongs to group 1 in the periodic table and the sodium which belongs to group 1 is also a metal. Okay? Now, I am going to find out the period in which the sodium belongs to. As you write the electronic configuration of sodium, you see that it is arranged in 3 different shells, right? That is, since the electrons are arranged in 3 different shells, it belongs to 3rd period in the periodic table. So, we can say that the sodium belongs to group 1 and period 3 in the periodic table. So, now I am going to explain a table and with the help of that table, you can simply predict the group number and period number of any element in the periodic table. Okay? So, now look at this table. Here you can see 2 columns, right? In the first column, it shows the number of electrons in the outermost shell and the second column which shows the group number in which the element belongs to. Okay? So, in the outermost shell, if it contains 1 electron, then it belongs to group 1 and if it contains 2 electrons, then it belongs to group 2. If it contains 3 electrons, then it belongs to group 13. If it contains 4 electrons, then it belongs to group 14. If it contains 5 electrons, then belongs to group 15. If it contains 6 electrons, then it belongs to group 16. And if it contains 7 electrons, then it belongs to group 17. And finally, if it contains 8 electrons, then it belongs to group 18 in the periodic table. Okay. So, with the help of this table, you can simply predict the group number of any element if you know the number of electrons in the outermost shell. Okay. Now, I will show you another table and with the help of that table, you can simply predict the period number of any element. Okay. So, look at this table. Here also you can see 2 columns, right? In the first column, it shows the number of shells in which the electrons are arranged and the second column, you can see the period number in which the element belongs to. Okay. So, if you look at this table, it is very much clear that the period number is actually equal to the number of shells in which the electrons are arranged. Okay. For example, if the electrons are arranged in 1 shell, then it belongs to the period number 1 and if the electrons are arranged in 2 shell, then it belongs to the period number 2. Similarly, if the electrons are arranged in 7 shells, then it belongs to period number 7. Okay. Now, with the help of these 2 tables, I am going to find out the group number and period number of oxygen. Okay. So, we know that the atomic number of oxygen is 8. So, how can we write the electronic configuration of oxygen? 2, 6, right? Okay. Here if you look at the electronic configuration of oxygen, you can see that the outermost shell contains only 6 electrons, right? First, I am going to find out the group number in which the oxygen belongs to. Okay. So, look at this table. Here you can see that as the number of electrons in the outermost shell is 6, then it belongs to group 16 in the periodic table. So, we can say that oxygen belongs to 16th group in the periodic table and this oxygen which belongs to the 16th group in the periodic table is a non-metal. Now, I am going to find out the period in which oxygen belongs to. Okay. So, with the help of this table, we can find out the period in which oxygen belongs to. As you look at the electronic configuration, you can see that the electrons are arranged in two different shells, right? So, as the electrons are arranged in two shells, then it belongs to period 2 in the periodic table. So, we can say that oxygen belongs to 16th group and second period in the periodic table. In a similar way, with the help of these two tables, you can simply predict the group number and period number of any element. Okay? So, now coming back to the Bohr model of an atom, you know that in a Bohr model, an atom consists of a nucleus at the center, and around the nucleus there are definite shells in which the electrons are arranged. Okay? So, as the distance from the nucleus increases, the energy of the electrons also increases. But what happens to the force of attraction between the nucleus and electrons as the distance between them increases? Yes, the force of attraction between the nucleus and the electron decreases as the distance between them increases. Okay? Now I am going to find out the electronic configuration of some elements. So look at this table. First I am going to find out the electronic configuration of lithium. Lithium has its atomic number 3, so its electronic configuration can be written as 2, 1. Now the next element is sodium. Sodium has its atomic number 11, so its electronic configuration can be written as 2, 8, 1. The next element is argon. Its atomic number is 18, so its electronic configuration is 2, 8, 8. The next element is potassium. Potassium has its atomic number 19, so its electronic configuration is written as 2, 8, 8, 1. Here you might have some doubt because in your previous classes you studied that the third shell, that is the M shell, can accommodate a maximum of 18 electrons. But here when we write the electronic configuration of potassium, the third shell, that is the M shell, contains only 8 electrons and the remaining 1 electron occupied to the next shell, that is the N shell. So why this change happened? It is a truth that the third shell, that is the M shell, can accommodate a maximum of 18 electrons, but always the last shell can accommodate only a maximum of 8 electrons. That is the reason why we put 8 electrons only in the M shell and the remaining 1 electron to the fourth shell, that is the N shell. Okay? Now we are going to discuss about the Bohr model again. And in the Bohr model, you know that the atom consists of the nucleus at the center, and around the nucleus there are electrons arranged in different shells. Okay? So these shells are called the main energy level, and inside these shells there are sub-levels or subshells. Now we are going to study about those subshells. Okay? In the periodic table there are mainly 4 subshells. They are S, P, D and F. In the first shell, that is the K shell, there is only one subshell. And for the second shell, that is the L shell, there are about 2 subshells. And in the case of the third shell, that is the M shell, there are 3 subshells. And for the fourth shell, that is the N shell, there are 4 subshells. The S is the first subshell for all the shells, and P is the second subshell for all the shells, and D is the third subshell, and F is the fourth subshell for all the shells. Okay? So now I am going to explain how these subshells are arranged in each of the shells. Okay? So now look at the picture here. Here you can see that the K shell, right? Since the K shell is the first shell, it contains only one subshell, and it is the S subshell, and it is usually represented as 1s. That means the S subshell of the first shell. Now considering the second shell, that is the L shell, since it is the second shell, it contains 2 subshells, and they are S and P, and it is usually represented as 2s and 2p. That means the S and P subshells of the second shell. Now considering the third shell, that is the M shell, since it is the third shell, it contains 3 subshells, and they are S, P and D, and it is usually represented as 3s, 3p and 3d. Now coming to the fourth shell, that is the N shell, since it is the fourth shell, it contains 4 subshells, and they are S, P, D and F, and it is represented as 4s, 4p, 4d and 4f. and we will discuss more details about the subshell in our coming classes. See you again.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.